Today we're going to be talking about something called pedigrees, and y'all saw this after the quiz on Friday, and you should have read about it a little bit, but these are charts that help us look at relationships for genetic disorders or any kind of heritable trait in a family. So here we have a sample pedigree, and then on the right side are your is the key for all the symbols that you might see in a pedigree. So right now, make sure in your notes you're filling out what these different shapes mean, because you're going to see them over the next few days. Alright, so the first one is the difference between a male and female. So a male is represented by a square and a female is represented by a circle. If you have a half shaded square, it means that that male is a carrier, but they're not showing the trait. So this would mean that the person would be heterozygous. So it would be one big letter, one little letter. Same thing with the carrier, female. It would just be the same thing, but in a circle. So again, a big letter and a small letter. Now, if the shape is shaded, that means they have that trait. They're expressing that trait. Whether we're looking at a genetic disorder, a sex-linked trait, or just, whether or not the person has a widow's peak or hitchhiker's thumb, something that we've talked about. Horizontal lines represent a marriage, and vertical lines represent children. So if you look at this relationship right here, this would be a husband and a wife. Alright, let's say, for example, this is Mrs. Martin. Alright, this is myself right here. Who would this circle represent? This would be my mother. And this would be my father. Who would this be? Alright, so let's look at this. So this is my mom, this is my father. This line represents children. It looks like my mom and dad has had 4 kids, 1 male and 3 female. So this circle in relationship to me would be a sister. This would be a brother. Alright, now let's think about this. Who would this square be? This square has married one of my sisters, so that would make this square my brother-in-law. And we can go a step further down. If my sister and my brother-in-law had kids, this would be my nephew. Going back up to the top, who would this be if this is me? This would be my grandpa. So you can see how it shows generations. So this would be my grandparents, this would be my parents, this would be my brothers and sisters, and these would be my nephews, or if there was a circle, it would be niece. So make sure you have all of this down. Alright, now here are some other symbols that you might need to know in case you have twins in your family. So if you have fraternal twins, it's represented by a marriage and then a 45-degree angle lines coming out. If you have identical twins, it's the same setup, except there is a line connecting the 2 siblings. So in your notes, there is a place for you to draw these symbols as well. And just a reminder, you can pause this video if you need to have more time drawing these symbols. So if you need to, pause it, and then you can come back to it. Alright, another example, remember a married couple is a horizontal line, so this would be husband-wife. Siblings would represent by these vertical lines, so this is husband and wife, and then this couple has had 3 children, 2 girls and 1 male. Make sure you've copied these in your notes. Alright, now, depending on the shaded figure, you have to look at the parents to understand if it's a recessive inheritance or a dominant inheritance. In order to do that, you're going to have to set up Punnett squares. And this is the tricky part about pedigrees, and we're going to walk through some examples. You have to be able to tell me if the pedigree is a recessive inheritance or a dominant inheritance by looking at the examples, or by just looking at the pattern of traits. So let's see, if this is a father and this is a mother and they're both not shaded in, this is the affected, I was looking to see if it's male or female, so this is the affected child. So how you know this is a recessive inheritance is that neither father or mother has the trait. They're not shaded in. However, they have to be carriers of that trait in order to have a double recessive affected child. And you can set this up with a Punnett square. A dominant inheritance, let's see, the dad shaded in, the mother is normal, and then you see that 2 of the kids are affected and 2 of them are not. So that would show that dad has to be heterozygous and mom has to be recessive in order to get 2 affected and 2 normal. Set it up with a Punnett square. Don't worry if you don't understand it now. We're going to walk through plenty of examples. Alright, so this is what you need to be writing down in your notes. So interpreting a pedigree chart. Here are the rules. So to determine if the pedigree chart shows an autosomal or X-linked disease, which would be a sex-linked trait, these are the things that you have to look for. If most of the males or females in the pedigree are affected, then the disorder is sex-linked, meaning if the figures that are shaded in are all male or all female or majority male or majority female, that means it's either going to be found on the X or the Y chromosome, which makes it a sex-linked trait. If it is 50-50 or found in both, the ratio between men and women, the disorder is something called autosomal, which means it's found on any of the chromosome pairs 1 through 22. So this is the first question you're going to ask yourself. Is the pedigree sex-linked or is it autosomal? And if you follow those simple rules, you're going to get it right. Alright, so here is an example. Is this pedigree autosomal or sex-linked? Look back and look at your rules. Look at the ones that are shaded. This one, this one, this one, this one, this one, and this one. Out of those, count how many are male. 1, 2, 3. How many are female? 1, 2, 3. If it's 50-50, then that means the trait is autosomal. Alright, let's look at the inheritance of color blindness. Alright, let's look. Out of the affected, you have 3 males and 1 female. So yes, there's found in both males and females, however, the majority is males. So this trait, for now, would be sex-linked. We'll talk about dominant and recessive in just a little bit. And it's sex-linked, again, because there's majority males than females. Alright, this is looking at the trait for tongue rolling. Count how many females and how many males. Alright, so it's going to be 4 to 6. And I know there's a majority females. It's not exactly 50-50, but you have to understand that it's found in both sexes, both males and both females, at a pretty high rate. So this would be, it's autosomal. This pedigree is autosomal. Alright, now the second question you're going to have to answer for the quiz is whether or not the pedigree chart is dominant or recessive. Alright, so that means that if that trait that we're talking about is passed on as a dominant trait or is it passed on as a recessive trait. And these are the rules that you need to follow, so make sure you've copied these down in your notes. If the disorder is dominant, one of the parents must have the disorder. If the disorder is recessive, neither parent has to have the disorder because they can be heterozygous. If the disorder trait skips a generation, then it's always recessive. And if the disorder trait is in every generation, it is dominant. So these are the rules that you need to follow in order to answer the question, is the pedigree chart dominant or recessive? So let's look at some examples. Remember, you can pause this whenever you need to. All right, here's the first example. So is this pedigree chart dominant or recessive? So let's look. First of all, is the trait expressed in every generation? That means is in every line, horizontal line, if you follow my cursor, do we have a shaded figure? And the question is, or the answer to that is yes. So that tells us automatically that this trait is dominant. All right, how about this? Is this dominant or recessive? So we're looking on this line, the first generation, there are no shaded figures. This line does, and this line does. So you can see that it skipped a generation. So the only way for it to skip a generation is if all of these parents are heterozygous. So the answer to this question would be recessive. All right, let's answer the following questions below about this pedigree. What family members are affected? All right, so that would be the shaded ones, going all the way back to the first thing we talked about today. Is it dominant or recessive, and how do you know? It should be dominant because it is found in every generation. Look at this example. All right, which family members are affected? The top square and the bottom circle. And you notice that it should skip an entire generation. So this trait would be what? If you said recessive, you were right. All right, here's another example. And I believe these examples are in your notes. Marfan syndrome is an example of being in both sexes, so that means it's autosomal. So remember, the first question, is it autosomal or sex-linked? And notice that it's in both males and females at an equal rate, or close to an equal rate, so we know it's autosomal. All right, it is expressed in every generation, meaning that it's not skipping, so that means it's dominant. So the answer to this pedigree chart would be it is autosomal dominant disorder. Another one is hemophilia. Remember we talked about hemophilia last week. This is considered a sex-linked trait. And let's look. Look at the affected individuals. There are 3 affected individuals and all of them happen to be male. This means that this is a sex-linked trait. It is only found on the Y chromosome. It also skips a generation, and therefore it is recessive. Here's one more example. See if you can do this one on your own. Look to see who is affected. It is all male, so it would make it a sex-linked trait. Here's another example. First ask yourself, is it autosomal or sex-linked? Look to see who are affected. You have 2 females and 2 males. That would be a perfect 50-50 ratio, meaning that it has to be autosomal, meaning it's found on the one of the 22 pairs of chromosomes that are considered autosomal. And this trait is also dominant because it is found in every generation. Alright, so again, we haven't looked at any examples with the carriers, which was what you found in your Harry Potter, which the second video is going to go over the answers of the Harry Potter worksheet. So make sure you have that out so you can make sure you get credit for it when I come back on Wednesday.